dear students, today we will learn a new module, Computation of Mode. So, if you see the definition, according to AM Tuttle, mode is the value which has the greatest frequency density in the immediate neighborhood. So, when we do this computation, when we learn this, you will come to know that we are deciding the model class where the frequency is highly concentrated in the immediate neighborhood. See, for example, 2-3 values will be there, or frequency values, there will be a marginal difference only between the highest frequency and the next highest frequency. So we will do the grouping table and analysis table to find out which value has the maximum frequency. That will be the model class. So this is how we are defining it as the maximum frequency density in the immediate neighborhood. When we will learn this module, you will come to know that why we are using this definition. This definition has got its own meaning. Frequency density in the immediate neighborhood, that will be the value of mode. So mode is also a positional average. If you recall, median, when I explained, I told you, median was also a positional average. The most frequent item in the series is known as the mode. That meaning, whichever the value which is getting the highest frequency, then that value we can call it as mode in the simple term. But there will be changes in that. So I'll tell you that the item which is repeated maximum times is known as the mode of the series. That meaning, again we are emphasizing that the value which got the highest frequency. But this assumption may not be true, as computation will be affected due to sampling fluctuations. So sampling fluctuations will be there. We have mentioned this for mean and median computation also. So hence mode is considered as the value about which the items are mostly concentrated. See, you remember the definition, where the frequency or the maximum values are concentrated in the immediate neighborhood. That is how we identify the modal value. Now, it is the value which has the greatest density in its immediate neighborhood. So, mode is also known as the most typical or fashionable value of a distribution. Now, we will see that how we are doing this. So, if you see this, just one simple example, size of shoes. Values from 4, 5, 6, 7, 8, 9 and 10. Number of persons values are there, 10, 20, 25, 40, 22, 15 and 6. So if you see this, the highest frequency is against 7, that is 40. The next highest frequency is 25, that is against value 6. There is marginal difference. So we can see that 7 is the mode of distribution with the highest frequency, because the difference is very high between the highest frequency value and the next highest frequency value. That is between 40 and 25. So we can, just by observation, we can decide the model class. In case of individual and discrete series, mode is the value which occurs more frequently than any other value. But this will be true only if there is marginal difference between the highest frequency and the next frequency. Now, if one value occurs more frequently than any other value, the distribution is called unimodal. In our example, what we explain now, 7 has got the highest frequency and only one value got the frequency, maximum frequency 40. So that is called the unimodal class. Whereas, if two different values have equal and maximum frequencies associated with them, the distribution is called as bimodal. Imagine in our example, if 6 and 7 are having the same frequency 40, then it is called bimodal class. Bimodal class computation, we have to use a different equation for continuous series and all, that I will explain. Here the point is, if all the values of the series are having unique, in that case mode cannot be determined. See, for example, we used all the values are having the frequency 40. That meaning we cannot compute the mode. Now, mode computation can be explained in 3 topics. As usual, we are dividing it into individual observations, discrete series and continuous series. Now, individual observation, computation is divided into 2. One is unimodal class and second is bimodal class. So, in case of individual observations, value of mode will be the value with the highest frequency. So, if we take this example, find mode for the following data: 10, 20, 30, 20, 10, 40, 30, 20, 40 and 20. See, if we have to do the tally marks. See, 1, 10, if you are saying that, you have to write the values, then you have to put the tally marks and frequency. 10 is repeated 2 times in the observation. That meaning we are putting 2 tally marks and we will convert it as 2 as the frequency. Like that we have to take for all the values. 20 has the frequency 4, 30 has the frequency 2 and 40 has the frequency 2. So value 20 has the highest frequency, so mode is 20, and this is a unimodal class. Now we will come to a bimodal class. Find mode using the following information. Values 10, 20, 30, 20, 10, 40, 30, 20, 30 and 20. Now we will see that how we have analyzed this. So values we are writing tally marks and frequency values. But here you can see that values 20 and 30 are having the same frequency, 3 each. Now, two values 20 and 30 have the same frequency. So, this is called a bimodal class. And in mode is ill-defined. Bimodal class and mode is ill-defined. There is no equation for calculating mode in the case of individual observations with bimodal class. Whereas for continuous series, we have a separate equation for computing mode if it's a bimodal class. Whereas for individual and discrete series, it's not possible. So individual observation, if it's a bimodal class, mode is ill-defined. But unimodal class, if the highest frequency is for one value, we can say that this is the mode of the distribution. So this is what I want to explain with this module. Thank you.